Good day to you all. So today in this video I will be explaining one problem from the question paper problem. So machine learning BCS 602 video paper, which is of Jan 2026. Okay, the problem which I am discussing today is how to solve the LU decomposition. Okay. So there are two methods to solve, and this question has been asked for 6 marks in the video paper, previous video paper. So first, in a row elimination method also you can solve, and the another way substitution method also you can solve the problem. So first we will see this method where we are considering the identity matrix, so where diagonal values are 1 and the other elements are 0, and the rest a value whatever the given matrix is there, that we are writing as such. Okay. Now what is our condition? We have to make L and U. So L means all the lower values should be occupied and the upper value should be 0, and whereas U means all the upper value should be occupied. So like that we have to make the L and U, right? So here first we have to make L of 2 1 as a 0, right? So for that we have to consider the L of 2 1, that is 4, and we have to make this value as 0. So we have to take 4 by 2 upper value, so which is equals to 2. So our first consideration is this value should be 0. So first we are creating the upper triangular matrix. Okay, so for that we are considering this. So 2 we will get, so this is called elimination method. So here the formula will be R2 is equals to R2 minus 2 into R1. If you apply this formula, the particular value of 2 into 1 position will be 0. So here 4 minus 2 into R1 value, whatever it is there, is 2 here. So 4 minus 2 into 2, which is 0. Similarly 7 minus 2 into 3, which is 1, and 3 minus 2 into 1, which is 1. Okay, so the final value for the first row 2 will be 0 1 1. Similarly row 3 also, this is 6 divided by 2 we are doing. So here what we want in this place 0. So 6 divided by 2 will be 3. So you have to consider 3 as a multiplier to make this location as 0, that is L of 3 1 location. Okay, third row first value, right? When you apply this formula to this, that is R3 minus 3 into R1, 6 minus 3 into 2, that is 0, and 18 minus 3 into 3, that is 9, and 5 minus 3 into 1, which is 2. Okay, the corresponding values will be 0 9 and 2. So these two values I am replacing in the given matrix A, that is R2 will be 0 1 1 and R3 will be 0 9 comma 2. Okay, so similarly for this, now the next agenda is to make 3 2 as 0. Okay, so 3 2 as 0, the value is 9 here. So if we use this matrix, this row, it will be easy. So the formula will be R3 minus 9 into R2. So when you apply this formula to these two particular rows, the value will be like this. Okay, 0 minus 9 into 0, that is 0, and 9 minus 9, that will be 0, and 2 minus 9, that will be minus 7. So 0 0 7 will be the our final matrix, and here all the lower values are 0. So upper value will consider it as we are considered as a upper triangular matrix. So in this formula, when we are solving, automatically we have taken the lower 2 1, whatever the lower 2 1 value we have solved here. So that is 2 here, and similarly here we have considered 3, that is L3 1 as 3, and so this is how we will be considering the lower values, that is L by 2 is equals to 2 and 6 by 2 is equals to 3, and for here 9 by 1, so 9 by 1, which is 9. So lower triangular matrix will be like this, you will be getting. Okay, and after solving you have to verify the problem. So to verification, so this is how you have to consider L and U, both L and U, to get the A. So 1 into normal multiplication, first row with the first column you have to do, that is 1 into 2, 0 into 0, and 0 into 0, all if you had, you will get it as 2. So 2. The same way 1 into 3, 0 into 1, and 0 into 0, so you will get it as 3 here. Similarly 1 into 1, and this 2 will be 0, so answer is 1. Similarly 2 into 2, 1 into 0, 0 into 0, so 2 2s are 4. If you solve like this, you will get the final A. So you have to solve the verification also in the problem, and the same LU method in the LU problem with a different method is being solved and uploaded in the next video. Please find out. Thank you.